Hello everyone, this is Vahe and this is the introductory video for experiment 4x. So in this experiment we're going to be using both LTSpice and Matlab to analyze circuits. So in fact we're going to do nodal analysis, and the essential points of what we're going to use in this experiment you already done in the previous labs and or homeworks. So now we put everything together and we'll be able to analyze circuit a couple of different ways to verify to see if we're doing things right. So on the right you're seeing the experiment document that you'll get. So let's kind of go into it and see what's really involved. Okay, let's take a look at the document. So as before, I'll walk you through it. Some of you are not putting your name, etc. It's you really should, but if you're uploading it to the proper location, should be okay. But please, when you start your work, put your name, email, etc. It'll help us out if there's any confusion. So in this experiment, we're going to analyze 3 circuits, okay? And each circuit is going to be done using nodal analysis. So I give you how the circuit looks like actually. But this time I'm not going to give you the sample files. You do it. You construct it. You already know how to do this in LTSpice. So what I want you to do is go ahead and construct the circuit. It's got 2 sources, 5 resistors. 6 resistors actually. Take it back. And then I've also marked where V1, V2, V3, V4, V5 as the 5 node voltages. Those things in the square things, they're actually just little text files or little textual information inside LTSpice. You do not need to enter that, right? I mean, I mentioned it up there, but you do not need to enter that. You just need to enter the circuit with the sources, run the simulation, and you know how to go to the nodes and click, and it shows you all the node voltages and etc. Right? You know how to do that because we just done that in the last experiment. Okay, so this is another one, but the difference in this experiment also is that now we're using a little more practical values. So you see the resistors are in kilo ohms, right? 10K means 10,000 ohms, 18K. So when you write K, LTSpice knows it's 1,000, so you don't have to put 22,000, just 22K. Also, like the current source, it says 1 milliamp, right? So it's 10 to the minus 3 amps. So instead of writing 0.0001 amp or something like that, 1 milliamp, right? If you write 1 M or 1 milliamp like that, LTSpice knows it's 1 milliamp. Okay, so these values are more practical. Even the resistor values are not random values. These are actually practical values that you can actually go by, right? So the numbers are a little different, but the entry is straightforward as usual. It's the way you did it before. Okay, so this is circuit 1. And what do you do with this? Well, I want you to construct the circuit in LTSpice, and when you do, and run the simulation, right? And to run the simulation, you need to make sure that the .op appears on the schematic, right? If you watch my previous videos, you know what that is, what that involves. So when you run the simulation, those question mark areas, right? When you click there, you can place the node voltages. So after you run the simulation and those node voltages up here, I want you to copy and paste that schematic with the simulated node voltages into this box. Okay, and you know how to do copy and paste. I'll kind of walk you through it maybe one more time just so that you know. And then the node voltages, just enter them in this table. Power absorbed, or what we call dissipated for resistor, enter them into this table. And then power generated with each source, right? What's the power generated? Well, it's the opposite of dissipated or absorbed, right? So you go into each source, it already tells you dissipated, right? For each source, just take the opposite of that basically, is what it is. So I know that's going to be a question, and I'll say to everyone, watch the video, but it's pretty simple, okay? And I'm going to show you an example of how to enter this circuit anyway in a few seconds, but that's what the first circuit looks like. The first circuit is just a pure LTSpice. There's no Matlab here. Now when you go to the next circuit, again, I give you the circuit. You should be able to enter it. It's pretty simple, right? But then what I want you to do is, before you simulate it, I want you to go and write the nodal analysis equations for this circuit. Okay, just like we did in homework 3. Homework 3 problem 1, we did that, right? I want you to do it for this circuit. Here this has 5 nodes, right? So it should give you 5 equations, 5 unknowns. And your inputs are going to be, dimensions of, in the dimensions of 5, right? So what I want you to do is write the nodal equations, find the matrix, find the matrices, put them in standard form, which gives you the matrices. You should get a 5 by 5 matrix, which multiplies the unknowns. And on the right side, you should get a 5 by 1, right? The A and the B matrix, which I showed in homework 3 problem number 2. I showed you what those were and how to enter it in, inverse A times B. You should have seen that. So what I want you to do here in this box is for you to enter the A matrix, the B matrix, and the solution that you get in Matlab. So this is a pure Matlab solution to this circuit that's shown. Okay? So you should already know what the V1, V2, V3, V4, V5 are from that, okay? Once you do that, then I want you to also go ahead and now build it and simulate it as usual. And when you do, when the simulation results show up, right, you're going to get values for V1, V2, V3, V4, V5. Those question marks, right, when you click on the nodes, those question marks won't be actually question marks. That'll be just numbers. And you also see a question mark down there by ground. I mean, that's going to be 0. It better be 0, right? You can double check that. But I want you to build this, simulate it, and then put the simulated node voltages being shown in the actual schematic, right? You've done that before. I just want you to take a screenshot of that and put it in there. And then, again, fill out the table for node voltages, power dissipated for the resistors, power generated. Same thing. Here, and here's another circuit. 6 nodes, right? I want you to write the equations for this. Shouldn't be that tough, right? Write the equations for 6 equations, 6 unknowns, right? You're not going to do it by hand. Matlab is your friend, right? Enter it in. Okay, the 6 by 6 A matrix, the B matrix, which is 6 by 1. Solve it numerically, and I want you to enter in your A matrix, B matrix, and the solution here, right? I mean, you can just copy and paste that directly from Matlab. You can just copy the output, the text, and just put it right in here. You don't even have to write anything in here. The only thing you do have to write is you have to write the equations, put them in standard form, and then your entry into Matlab, right, is what I want to see over here. Okay, the A matrix, the B matrix, and the solution, just like problem 2 shows on homework number 3. Okay, and then the same deal, right? You build the circuit, you put the circuit in LTSpice as it's shown like this, run it to get the values of the voltages, put them in the table, get the power absorbed for the resistors. I mean, you just hover over and write the number, and it's not that difficult, okay? And then get the power generated for each source. Had to be careful with this one, right? Power generated for a source. Power dissipated for a source is always power dissipated for a resistor is always positive. Power generated for a source, right? Some source may actually generate. Some sources may absorb, right? Remember, LTSpice only gives you the power dissipated, right? So if you see power dissipated is minus 2 watts, that's power generated plus 2 watts, right? So just remember that. Okay. So if I'm asking for power generated, you go to the power dissipated for the source and report the opposite value. All right. So this is how the template looks like. It's pretty straightforward. It's very much like before, but now we're combining things, right? We're combining what we learned to do more things, but it should not necessarily be more work because Matlab and LTSpice is doing most of the computation. You just have to put them in the right form and present it in the right form. Okay? So this is how the template looks like. Should be pretty straightforward. Now let me show you again, in case you want to see it again, you want to see me do something here with the enter of the of the components. So let's just enter a circuit with the values, and let me just go through it again just so that you understand what I'm talking about. Okay, so let me go grab a voltage source. You can go here, by the way, and you know, pick your sources, right? Like a current source. You know, here's a current. Okay, and you can come down here and, you know, put it someplace, you know, and who knows, we make it maybe some value, right? Let's say I want to make it 0.2 milliamps, 0.2 M. I can just leave it as 0.2 M, by the way. It'll know it's milliamps, but I can also add in the A, so that's also okay. So this is a 0.2 milliamp current source pointing down. You know, resistors, right? I mean, you could go to this thing and pick a resistor, right? Here's a resistor. I'll tell you 3 ways of entering a resistor. Here's a resistor. You okay it, and you know, you put it here, maybe I don't know, make this 4.7 kilo ohms, right? 4.7 K, right? So this is 4,700 ohms. There you go. Okay, another way to put in a resistor is go right here. There's a little resistor symbol. Click that, and you have a resistor again. Let me rotate that. Control R to rotate, right? Control R to rotate. I'll put it down and right click to not keep entering the same resistors again. Or maybe you want to do that, right? Let me go through and do that again. Okay, here's a resistor, right? Okay, let me rotate that. Control R, and I just put it down. And if I move it, there's another one here again, right? And then put that one down. If I'm done putting down resistors, I can stop here, or I can just keep going, right? But let me just stop here for a second and say, okay, this one resistor, 5.6K maybe, right? I mean, I'm kind of just randomly picking values, but you know, on the simulation that I want you to do, obviously, right? There are actual values that you need to put down. Okay, so 3.3K, we put it there. Okay, we're good. I want to grab a voltage source. Well, I mean, you can go in here and, you know, find where it says voltage. Okay, but I'm lazy. If you just type V on your keyboard, right, you can sometimes get a voltage source depending on how your keyboard shortcuts are, right? But you know, this is always here, so you can just okay this and, you know, get a voltage source. You can just try out to see if that works. Like, for example, typing R does get your resistor. I just typed R, okay? Control R rotates it and, you know, puts it down. Okay, maybe I make this 1 kilo ohm, 1,000 ohm resistor, right? There we go. And then, you know, zoom out and maybe zoom out a little more, and that's how our circuit is kind of looking like. Voltage source V1, I don't know, make it 10 volts, right? 10 volt source. Maybe I put another voltage source, right? Okay, well, I'm lazy. I don't want to go up there again. I can use copy from here, right? I can do is copy and, you know, go over here and put it down. Okay, make that 5 volts, right? 5 volts. I need ground. Well, I can get the ground from here, right? Or I can just type in G and get a ground, okay? And then just wire things up. Here's the wire. And you can almost, like I said, you can just go through the components. It's almost like you're shorting them out, but you're not. If you come here and just do a right click, everything just turns out great, okay? And then get more wires and just kind of go through and click, and it does the right thing. I finally, you know, get the ground symbol, and I got my circuit, right? It's as simple as that. And then save it, you know, save as circuit 1, for example, or whatever you want to call it. You know, file, save as, I don't know, circuit 1, circuit 2. It's up to you. Draft 1, call it draft 1, okay? And then zoom out, and you're in business, but there's no simulation command, right? There's no simulation command. When you hit the running guy over here, it's going to ask you what simulation you want to run. If you have a clean circuit like this with no simulation command that shows .op, operating point, right, is what we're looking for, it doesn't know. It doesn't know any of this. So if you click it, you get this edit simulation command. So you should go and choose DC operating point, okay? And when you say okay, and once it's on the schematic, it already ran the simulation. Get rid of this box, and now you can go and probe around. I've already done this, but I'm just showing it to you again, okay? If you click on these nodes, you get the voltages at those nodes. Those are your node voltages with respect to ground. By the way, if you click on ground, you get 0, right? I mentioned that before. I mean, obvious. But if you click on it, that's what you'll see. And now you know the voltages across everything, right? Look at R4. Left side is 10 volts. Right side is 7.91 volts. What's the voltage across it? Left to right, plus minus 10 minus 7.91. So that would give you 2.09, something like that. 2.09, right? And you can calculate the current through it if you were asked, okay? But you should be able to do this. And now, you know, if this was V1, V2, V3, V4, you enter it on the table, right? You enter it on the table. And you can also write the nodal equations. But when I ask you for the nodal analysis equations, you'll notice that I only ask you for nodal analysis equations for circuit 2 and circuit 3, which only has resistors and current sources, right? With the voltage sources, it's pretty easy too, because actually with voltage sources, I didn't ask you nodal analysis, but with voltage sources, it's easy because if you look at the left node, right, it's already 10 volts. Look at the right node, it's already 5 volts. So basically, we don't write nodal analysis equations there. This circuit has 4 nodes because we don't count ground, right? But you only have to write 2 equations. So it's actually easier with the voltage sources because the nodal analysis equations at that node are unnecessary. There's no KCL necessary. We know the node voltage, right? 10 volts, 5 volts. We know that. But I only ask you for the Matlab analysis and the writing of the nodal equations for the second circuit and the third circuit. Okay. Now, what else can we answer from here, from the circuit? Number one, the power absorbed and or power dissipated means the same thing for the resistors. Take your cursor, hover over it, read the lower left side. Okay. Dissipation says, you know, for this one it says 4.349 whatever. Okay, it's about 4.35 milliwatts, right? So it's 4.35 times 10 to the minus 3 watts, okay? Go on another resistor, okay? Dissipation is now 13.33 milliwatts, okay? Anytime you go on the resistor, the dissipation will be positive, for sure. Now, when you go hover over the sources, the voltage sources and the current sources, they may be positive, they may be negative, right? But remember, LTSpice only tells you the dissipation, right? So let's go to this V1 source. If I go over it, it said dissipation is minus 20.85 milliwatts, right? So if you were asked for the dissipation of this source, how much power dissipated or how much power is absorbed, same word, we would say minus 20.86 approximately milliwatts. But if you're asking for the power generated, I have to negate that, right? So dissipated minus 20 means generated plus 20. So actually this source right here is generating, okay, it's generating plus 20.86 milliwatts approximately. So this source is generating. Go to the 5 volt source, it says dissipation 1.01 milliwatts. So that one is actually indeed dissipating. But when we talk about a voltage source, we don't say dissipation really. We're saying it's really storing 1 milliwatt of power, right? So it's being charged, right? So it's actually taking in current. So it's not actually generating. It's actually dissipating, right? So this thing is dissipating 1 milliwatt. But if we're asked, how much power is this 5 volt source generating? We would say minus 1 milliwatt generated, right? So if you're asked for generated, just take the dissipation values and put a negative sign in front. Let's look at the current source here. 1.13 milliwatts dissipated. How much is generated? Minus 1.1 milliwatt. So basically, the source is also being charged actually. It's absorbing the power. But unlike the resistor, it's not giving it out as heat, it's storing it, right? So current source 0.2 milliamp, voltage source 5 volts, they're actually absorbing the power and storing it. And you can tell that because their dissipation values are positive. Okay, whereas this one, a 10 volt, it's actually minus 20 watt dissipated, which means it's generating. It's generating plus 20. So if you're asked for generated though, this one is generating, you would say plus 21, about 20.85 milliwatts. This one is generating minus, right? This one is generating minus 1 milliwatt, minus 1.13 milliwatt, right? So I hope that makes sense. There's nothing else I need to cover because you actually know everything that's being used in experiment number 3. The experiment 4, I'm sorry. Experiment 4X is using LTSpice and Matlab in ways that you've already used. You've used Matlab like this to calculate the node voltages in homework 3. And you used LTSpice to calculate node voltages for experiment 3. You've done this before, but now the circuits are a little bigger and the numbers are definitely more practical, right? So you normally don't see such low values like 1 ohm, 2 ohm like we did before. These are more practical values. You see typically, you know, in circuits that we are processing signals with, you see voltages in the tens of volts like this. You see resistors in the kilo ohm range, and you see currents in the milliamp range. So these are more practical set of values. So this is all I had to say. Like I said, the only thing that's a little bit different now is I'm asking for power generated in the sources. Very easy. Just go, look at the dissipation value, and put a negative sign in front. Or what LTSpice is reporting. And that'll give you the generated instead of dissipated. So anyway, I'm already up to about 23 minutes on this video. I hope you watch it through, and I hope you watch it in 1x so I don't sound like a chipmunk. Yeah, I hope this helps you out. This stuff will be posted soon, and by Monday morning you should have access to all this. So thanks very much for watching this video. And I hope it helps you with the experiments. The key with the experiment is do it early. Do it during your 3-hour period that you have during the week. Do not leave it until Saturday night or Sunday night if you can help it. Okay? Please use your experiment lab time. And you won't have any issues with these things. They're very straightforward. I'm giving you everything that you need to know. Okay? Thanks very much. Have a good night or a good morning. And I will be seeing you soon. Take care of yourselves and always stay safe. Bye. See you next time.